Hi, my name is Edgar Turcan. I'm chemical engineer and a student of the BYU pathway. I'm going to explain how I would write functions to find the intersection and the union of the two sets without the built-in methods. The intersection of two sets to find intersection, my approach is to iterate through the smaller of the two sets and check wherever each element also exists in the larger set. This is efficient because setup lookups O1 on our variables, but the step-by-step uh, take two sets, A and B. That's for example, and then determine which set is smaller and create an empty set called result. I loop through the smaller set, but if an element is also found in the larger set, I add it to the result. And finally, I return this result. But the big O since I only throw the smaller set and each lookup in the constant type. The overall performance is ON. But in other case, the union of two sets, for the union, I create a new empty set and simplify at every element from both sets because sets automatically avoid duplicates and this produces a correct union. Try to explain the step by step and create an empty set named result. Loop through at the set A on B and add each element to result. Loop through the set that they do the same and for return this result. But at the big O, I add all elements from the setting, giving all the complexity. In this case, O, A plus B. And try to explain this example in I have two sets, A, which contain 1, 2, 3, and B, 2, 3, and 4. The intersection is 2 and 3 because that's the element repeats in this case. And the union, I set all this set and try the two union in 1, 2, 3, and 4. But in some cases, I have an empty set. For example, if I had an empty set named A, but in B I have 1, 2, 3, the intersection is nothing because not much elements repeat, but the union is 1, 2, 3 because take all these elements and make this union. And thanks for watching the video.